Hello, my name is Victor. I am one of the product managers at GitLab, and me and my team, we are responsible for GitLab's Kubernetes integrations and infrastructure as code functionality. In this series of videos, likely in 3 videos, I would like to demo you how GitLab can help you if you are an infrastructure engineer, an SRE, or if you are a platform engineer who's setting up automations for your teams, or if you have a good platform engineer and want to benefit from their work. Hello, in this first video, I'm going to show you how infrastructure engineers might benefit from using GitLab. For this, I've created a project already, this demo info platform, and I'm going to walk you through the main features that we used in this case. What we want to do in the end is to allow our customers, our software developers, to easily deploy their workloads to a staging or dev environment and to production. And in this case, they will actually deploy this potato hat project, but that's not really our responsibility. That will be around the platform engineers. But we have to provide that environment for them, that infrastructure. And what we are going to do, what we do in this project is actually to run a Terraform project that sets up the nested networking, a GK cluster, and a few other things that I'm going to go into more depth here. We run this Terraform project using GitLab, and it's very simple to run Terraform in GitLab. First, we provide you a template that you can build upon. And in this case, as well, what we provide you is support for OpenID tokens. And with GCP, instead of storing a long-lived token somewhere in a variable in GitLab that's insecure and then you have to take care of, what we're going to use is this OIDC token, and we are going to authenticate with GCP using this token. For that, we need to set up a few things for the GCP authentication, and specifically this file, the Google application credentials file here, will contain a reference to our OIDC token, as you can see in these lines. And with this and a bunch of setup on the GCP side, we are ready to run a Terraform project against GCP. There is documentation on how to use OIDC with Google Cloud, AWS, Azure, or actually in any other OIDC, not provider, but whoever accepts an OIDC token. Besides providing you the template to run Terraform, another nice thing that GitLab provides is a Terraform HTTP backend that you can use without any configuration from GitLab pipelines. And of course, to run all this machinery, I need to configure several Terraform variables. As you can see here, some of these are predefined, the ones that start with CI_, while others are actually defined as CI/CD variables in this project under the CI/CD settings. All in all, once I have the OIDC set up and I have this very simple Terraform configuration, I can just run this Terraform project and the cluster will be created. Together with the cluster, what we want typically is a standard cluster. You could create a separate Terraform project to install Flux and Agent K. In this case, I added to the same Terraform project for simplicity. But basically, here we deploy Flux. Flux has an amazing CLI, but if you prefer to manage connections through Terraform and through code, then this might be your approach as well. We will use a GitLab deploy token to bootstrap Flux, and in the end, Flux will write back to this GitLab project its manifest. In order to write back, we actually don't need only a deploy token, because deploy token will be used by Flux in the cluster to retrieve its own definition from GitLab. On top of this, we have a project access token that authorizes Flux to write to this GitLab repository. So this is how Flux will be able to create this Flux system directory where a typical Flux starting configuration resides. On top of installing Flux, we actually install agent K, but we do it with a little bit of twist. We register an agent with Terraform. We created namespace. We store the token needed for the agent to authenticate with GitLab in the cluster. But after that, we store files in this Git repository. And actually this agent Helm remise file, as you can see, will be put under the Flux watched directory, and Flux will deploy the agent with the configuration we provided. Together with that, we configure the agent in the repository side, as you can see it here, and this is what we do. In the end, we receive this agent K YAML file that deploys agent K with its Helm chart and the values as we prefer to have it. And it creates this config YAML and the base config YAML, because we are going to edit the config YAML later in a different video. This almost concludes the demo. Very minor addition to generic environment management is the environment's functionality in GitLab, where we show you the latest pipeline and its status. And in case of Kubernetes, and if you have the agent configured, you can actually set up this view to show you either the whole cluster or subset of your cluster. In this case, this is my whole cluster. It's a relatively small one, as you can see, just for this demo. And you quickly have a quick overview of the cluster state. The sync status is unavailable because I didn't define a Flux resource to watch. But for example, I could add here the core Flux controller to see if Flux works or not, or doesn't. And this concludes the demo. In the next one, I'm going to speak about how platform engineers can benefit from using GitLab and how GitLab can help them.